Hi, this is David Davis from Actual Tech Media. We're here at the Emerging Technology Summit, and I'm excited to be joined by Mr. Rob Pegler. He's the CTO of Symbolic IO. How you doing, Rob?
I'm doing great. Thanks for having me at the show. It's been a good event.
Good, good. Well, thanks for being on. The Actual Tech Media audience, I mean, we're always looking for new emerging technology, innovative solutions, and I've been learning a little bit about Symbolic IO, and I must say my mind is a little blown right now. So first off, tell us what Symbolic IO is and what you all do.
Sure. So good question. So Symbolic IO started about 4 years ago, founded by a guy named Brian Ignamarello, who was the CTO at Hewlett-Packard Storage, amongst other places. So he and I both have very deep experience in the storage industry, if you like. And we're a 26-person startup right now, based in Homedale, New Jersey, at the original Bell Labs building, which is a very historic building where the transistor was invented, amongst other things. Wow. So very cool to be working there. So our mission is really twofold. We have a lot of intellectual property, patents and things. Brian has done a lot of great work in this area. That revolve around the transformation or encoding of binary data. Right? We've been storing binary kind of in raw form forever, since the advent of disk over 60 years ago. So instead of taking raw binary data and persisting it or storing it on a disk, we encode that and we create what we call symbolic bit markers that represent the data but are much smaller, much more compact, along with instructors that tell a CPU how to reconstruct this data in memory, right, inside the CPU, which is very important. CPUs are the fastest thing we have in computing today, so we want to take advantage of that. So that's a piece of the puzzle. The other piece of the puzzle is what we call a store module. Now, the memory industry for about a year has been making persistent memory, NVDIMMs if you like, and we use them as store modules in our Symbolic IO software. So we take those store modules and we persist the markers, not the original data, that would be too wasteful, but we persist the markers in there, and those markers, again, very efficient. So when the application reads data, right, number one, the data has to be in memory. It's got to come from somewhere, so we're always in memory, which is very helpful. And number two, the markers are very efficient because they're very small, and then the CPU can reconstruct them at CPU speeds. So the performance impact is profound, but also the storage, what we call amplification, is also profound, taking a relatively small amount of memory and storing much more data than the memory could, otherwise physically hold.
So what are some of the use cases for this?
Yeah, that's a great question. So there's a simple way to think about it. Whatever you would use a server for, and Iris, which is our brand name for our server, is a 2U platform, garden variety looking server, right? Whatever you would buy a server to do compute workload done, never mind the storage piece for a bit, but to get compute workload done. So if you're, for example, in retail, you're doing relational database, you have customer data, you have transaction data from your suppliers, you want to run analytics on that data. So there might be 40 or 50 different workloads that you as a retail operation would want to run, and you'd want to run it on servers. So not only are all those fair game, but especially applications which use a lot of data in memory and try to run in memory as often as possible, right? So if you take that in a regular server now and expand that ability to run in memory, number one, your processing becomes much faster. Number two, you can ingest more data per unit time, which is really great if you're in, say, a banking industry and you're doing financial analytics on transaction data, on stock ticker data. If you're an oil and gas company doing seismic analysis with all this data that is very patterned, right? You're looking at sonar waveforms and such, and you want to analyze that data, right? The whole key is that data has to be in memory, otherwise the CPU has nothing to do. So lots and lots of different workloads are fair game for this. Again, simplistically speaking, anything that can run in a server.
Okay, and especially applications that need a massive amount of data and they need really high performance.
That's correct.
IO access to that data.
You bet, you bet. So the world of efficient bit markers, having the CPU do all the work, it's as fast as it can get. Let's put it that way.
Very, very impressive. So, I mean, I want to learn more about what you all are doing at Symbolic IO. I know our audience does as well. What do you recommend for more information?
Right. Well, there's a couple of ways to do that. You can always go on the internet and look at symbolicio.com. But even more so, we're starting to engage in the field with partners like Deltaware starting to expand the message out. Again, came out of stealth in May, starting to ship, late in the year we'll be shipping product. We already have proof of concept customers, but working with partners, learning more about that, attending events like this, hearing talks about the technology, but more importantly, the aspect around the businesses and how we benefit those by doing very efficient computing.
Excellent. Well, thanks so much for your time today, Rob.
My
Appreciate
pleasure.
it.
Thanks.